Hey everybody, and welcome to our next video in Unit 1, our next and last video, which is going to be all about accuracy and precision. So in order to get this unit started, what is the difference between accuracy and precision? A lot of people tend to think that they mean the same exact thing, but in fact, their definitions really can't be any more different from one another. So a great example of a way that I could start to differentiate these two for you is by thinking about chocolate chip cookies. So when I want to make chocolate chip cookies, I expect to make something like this picture is showing, something that's very gooey, something that's relatively tall, and you bite into it, and you know what I'm talking about, the perfect cookie. But I get so mad when I make my cookies because they always end up looking like this. And no matter what I do, I can't seem to make cookies that don't look like this, where they're very, very flat. They still taste fine. They still taste like a cookie, but my cookies are always so flat. And I found that there's a reason why my cookies always tend to look like this. Not the reason, but we call that something. When every time I try to make a cookie, no matter what I do, it comes out the same way every single time. And that's going to start telling us the difference between accuracy and precision. So in this case, I am very precise when I make my cookies. And precision means that you get the same result over and over and over again. So whenever I make my cookies, like I said, no matter what I do, my cookies always look the exact same way. I'm very, very precise when I'm making them because I get the same result every single time. And we call that precision. It's not necessarily what I want my cookies to look like. I would like them to look very gooey and delicious every time, but they don't end up that way. And that's our other definition, what we're going to get into after this. But precision is getting the same thing over and over and over again. So another example can be when you're finding the mass of flour, maybe using two different measuring cups. On the first measuring cup, maybe you mass 1 cup of flour and you get 135 grams. Whereas you use a second measuring device and you get 120 grams on using another measuring device. In this case, you're not very precise. You didn't get the same result over and over again. Okay, that's a lack of precision. So as chefs, what do chefs tend to do in order to increase their precision? I'm sure a chef has taught this to you, but you're supposed to level off whatever you are measuring with. And that's a good way to increase your precision so that you do get a much more close set of measurements. That 1 cup for one person is very close to 1 cup for another person. So again, you're trying to increase your precision, and you could do that by leveling the top off. Whereas accuracy is not necessarily getting the same thing over and over again. So I would say I'm pretty accurate when I make my cookies because I make cookies every time, right? And they look like what they're supposed to look like generally, other than the being flat part. So precision, if that means getting the same answer over and over again, accuracy is getting the right result or getting the correct result. So if I was accurate when I was making cookies, I would make the cookie that I'm intending to make, the very big, ooey gooey, chewy cookie that I showed in that first picture. So if I'm accurate, that's what I'm getting, what I'm looking for. So the way you can tell if you're accurate or not by measuring flour is we can't necessarily say that 1 cup of flour is equal to 1 cup of flour because in fact, the best pastry bakers don't measure with measuring cups. They actually measure by mass. That's the most accurate way of getting 1 cup of something. And you'll see on here that flour's crazy because if you look at all of these different types of flour, 1 cup of flour, depending on how you obtain the flour, if you just dip it in the container, or if you sift it first, or if you take a spoon and you spoon it in the measuring cup, you're going to get different masses every time. Usually for bakers, if they're trying to be the most accurate, what they'll do is they'll mass their ingredients because they get the most accurate measurement that way. And hopefully when they're more accurate, they will also increase their precision. They get the repeatable results every single time. So let's take a look here. Precision is getting the same result over and over again, whereas accuracy is getting the correct result. Let's say you're making cookies, and if you are the best baker, you are always accurate and precise. So what does that look like? That means you get the same result, the desired result, every single time. You make cookies one time and they look like this. That's the picture I showed you in the beginning. You make cookies a second time and they look like that. You're like, oh, I did it again. They're perfect. You make cookies a third time and you're like, yes, again, they're perfect. And a fourth time, you're like, oh my God, I am a master of making cookies. You are accurate and precise every time. You got the desired result every single time. Let's say you're accurate, but you're not necessarily precise. You made a good cookie every time, but you're not really precise in the way that they appear. The best image I could use to find this one, you might have seen something like this. So if you change the ingredients just a little bit, you're going to get a different variation of the cookie. So if you look, that one on the upper left-hand corner has the most flour in it. Those cookies tend to be very tall. Maybe I need to add more flour to my cookies. I don't know. If you look on the upper right-hand corner, you'll see if you add melted butter rather than chilled butter, those cookies tend to be flatter. So let's say you baked a cookie the first time and you got this one right here. Then you baked a cookie the second time and you got this cookie right here. Then you baked a third batch of cookies and you got this cookie right here. They're all still good cookies, but you didn't get the same result every time. So you're accurate, but you're not precise. If you're like me, you're precise, but you're not accurate. So I get the same thing every time. Here's my first batch of cookies, big and flat, right? I make them again, big and flat. Third time, big and flat, and then there they are again. So not what I'm intending to make every time, but I make the same thing every time. I'm precise, but I'm not very accurate. On the other hand, if you're neither accurate nor precise, maybe you don't even make a cookie. Maybe you make something else, but let's pretend you do make cookies every time. Maybe the first time you make cookies, you get something like this, right? Where they're pretty small and they're very high. Maybe you have too much flour in them. The next time you make cookies, you get this, and you're like, what the heck went wrong? You got one giant cookie there. Maybe the next time your cookies look pretty good, right? They kind of look like Chips Ahoy. They're a little crunchy, but not too bad. And then you make cookies again and you're like, what did I do wrong this time? You're all over the place, okay? You're neither accurate nor precise. So that's the big differentiation between accuracy and precision. Precision's getting the same answer over and over, whereas accuracy is getting the correct answer. And you could be one and not the other. So of course, as chemists, we don't just like to talk about accuracy and precision, but we like to do calculations with accuracy and precision, and that's exactly what we're going to do here. I'm going to get you introduced to determining mathematically, are we accurate and are we precise? Are we both or are we neither? The way that we can determine if we're accurate is by using this equation known as percent error. And you've actually used this already back in that sand and salt lab, what we did at the very beginning of the year. So in order to calculate your accuracy, how correct are you? You would take your experimental value, whatever you got as a result of the experiment. You would subtract from that the actual value. That's what you're striving to get. You would divide that by the actual value again, and you would multiply that whole thing by 100, and that gives you a percent error. And what we're going to see that in this class, that should be a check mark there, so let me move my picture. We're going to say that in our food chemistry class, if we get a percent error of less than 10%, we are going to say, yes, we are accurate in our measurements. Let's go ahead and do an example with accuracy. So it says a box of cake mix states that it can make 12 cupcakes. However, you only made 11. We want to know, are we accurate in our cooking skills? So let's go ahead and identify what's our experimental value and what is our accepted value. So our experimental value should be this 11 right over here, because that's what we made as a result of this experiment, right? We're not actually experimenting here, but when we did it, we made 11. It's our experimental value. The box states, however, that we should technically make 12 cupcakes. So in this case, that 12 is going to be our accepted value. So let me get a different color here. So this 12 is our accepted value. I'm just going to put ACC next to that. Whereas our 11 is our experimental value for that. That's what I got as a result of doing this. And we can calculate our percent error from this. So let's go ahead and do that down below. My percent error is going to be equal to my experimental value, which I found to be 11 cupcakes. Or I'll put, cupcakes for this. You don't have to necessarily write units, but I'm going to include units here because why not? My actual value, my accepted value, the box says I should make 12 cupcakes. And I'm going to divide this whole entire thing by 12 cupcakes on the bottom. And because this is a percent, we're going to multiply that by 100. The way we would solve this is you want to do the top and then divide it by the bottom. So 11 minus 12 is going to give me -1. And I'm going to divide that by 12, and I'm going to multiply that by 100. And when I get that answer, I should find that I have about -8.3% error. So if you consider, were we accurate when we were making these cupcakes? We did get a percent error less than 10%. So we would say, yes, we are accurate in this case. We had a pretty close measurement, enough to say we got the job done. We did what we were supposed to do. I also want to mention that I did get a negative percent error. The reason why we got a negative value just shows that I got less than what I was supposed to get. I had 11 cupcakes and I was supposed to make 12, which is why my percent error is negative. My percent error would be positive if I produced more than what I was supposed to. So just keep that in mind as you do percent error problems. Let's talk about precision on the other hand. So how do we determine how precise we are? We can do this by using a similar equation. It takes a little bit more work, but it's not necessarily hard work. You can calculate a percent precision, and your percent precision is equal to the mean absolute deviation, and we're going to divide that by the mean, and we're going to multiply that by 100. I'm going to always give you a chart to set this up in, so you'll kind of know how to fill the chart out, which is what we're going to do on the next slide. It's much easier to be precise, I found, than it is to be accurate. So we're going to say that in our chemistry lab, if we get a percent precision less than 5%, that's going to be considered good. So if that means our values are 5% from one another. Let's go ahead and try this last problem. It says you measure 1 cup of flour 2 times. Your first mass is 127 grams. And your second mass is 139 grams. We want to know, how precise are you? Are these measurements close enough to one another to be considered precise? What I'm going to do for you, like I said, and I'm going to set up a chart that looks like this. So I will give you exactly however many spots you need in order to figure this out. Notice that I give you 2 trial numbers, and that's because I have 2 values here. This is going to be my first trial, and this value is going to be my second trial. So I'm just going to take these numbers and write them in the chart here. So 127 grams and 139 grams. What I want to do is find the mean of those 2 numbers. And remember, the mean is a fancy word for the average of those 2. So if I find the average of 127 and 139, so I'm going to add them up and I'm going to divide by 2, I get 133 grams. This is my mean for those 2. Then what I'm going to do is I'm going to find the absolute deviation. So how far is each individual mass from the mean? But I want to take the absolute value of that. So I'm going to take 127 grams, so I'll write it here, minus 133 grams. And when you do that, you're going to get -6. But it is the absolute deviation, so I'm just going to change it to 6 grams. I'm about 6 grams from the average. And the second one, I'm also going to do the same thing. I'm going to do 139 minus 133, which also gives me 6. So to find the MAD is the mean of these two values, the mean of the absolute deviations. So if I find the mean of 6 and 6, 6 plus 6 is 12, divided by 2 gives me 6, I'm going to get the same exact value again. So to calculate a percent precision, all I need to do is take the MAD, in this case is 6 grams, and I'm going to divide that by the mean, which is 133 grams. And I'm going to multiply that by 100. And when we do that, we happen to get, now this is one significant figure, so I'm going to round mine to 5% precision. Is this set of measurements precise? We are 5%. So we would say yes, this is in fact a precise set of measurements. 139 and 127 are within 5% of one another. Of course, that was only one practice problem for each, so we will do more practice problems in class. I have a couple of labs lined up. We're going to calculate accuracy and precisions for a bunch of different measurements. But as always, if you have any questions, please feel free to ask me in class. Otherwise, I will see you in our next unit, which is all about chemicals, and we're going to start to talk about elements and compounds and all that fun stuff. So I will see you then. Bye.